Alright guys, so we're going to move on to chapter 3 today. Before we start doing chapter 3, we're just going to do some SOHCAHTOA review, sine, cos, and tan review. So, just some basic things. Let's look at number 1. Find each of the following to 3 decimal places. Sine 27, cos 56, and tan 78. So all you need to do is pull out your calculator, I can't pull it up on here, and make sure it's in degree mode. And then just punch in sine 27, cos 56, and tan 78, and you should get the same answers that I'm going to write up on here. Alright, so sine 27 should give us 0.454, I just rounded to the nearest thousandth. Cos 56 is 0.559, and tan 78 is 4.705. Now, that's if the angle is given to you. But what if the angle isn't given to you and the ratio is given to you? So in that case, you have to do the inverse. So on your calculator, there's a button called sine -1, cos -1, or tan -1. So you're going to just go sine -1 and put in the ratio 0.602, and that's going to give you an answer of 37 degrees. For cos, again, we're just going to put in, punch this button on your calculator, cos -1 of 0.309, and you get 72 degrees, and tan x of 0.445. So the angle that gives us this ratio is 24 degrees. Alright, so let's look at a standard right triangle ABC, and let's say that we have given to us angle A here. Well then, that means that this side over here, BC, is the opposite side. So BC is opposite to angle A. That means that AC is the adjacent side, and always the side across from the 90-degree angle, the longest side, is called the hypotenuse. Okay? So, the ratios in a right triangle are as follows. Sine A is opposite over hypotenuse. So that means that if we want to find angle A and we use the sine ratio, we'd have to divide the opposite side by the hypotenuse and then do the inverse to get angle A. Alright? If we want to use the cos ratio, cos of angle A is adjacent over hypotenuse, and tan of angle A is opposite over adjacent. So from there, we can remember these trigonometric ratios, which apply to all right triangles, as SOHCAHTOA. So what that means is sine is opposite over hypotenuse, cos is adjacent over hypotenuse, and tan is always the opposite side over the adjacent side. Okay, let's look at this example. Solve this triangle, x, y, z. So we have two sides given to us, and we want to find, let's say for example, we want to find angle x. Okay, well if we want to find angle x, that means that tan is the opposite side, xy is the adjacent side as already labeled, and remember that the hypotenuse is always across from a 90-degree angle, so that's the hypotenuse. So to find angle x, we use the two sides that we know. We have this side and this side, so that's the opposite and the adjacent side, which if we look back up here, opposite and adjacent, that's the tan ratio. So tan x equals opposite over adjacent, tan x equals 10 over 6. So then to get x, we have, which is an angle, we have to do the inverse tan, which again is the -1. Which then gives us 59 degrees. So 59 degrees in there. We also know that this is a 90-degree angle. This is now 59 that we've discovered, so it's easy to find out what this angle is. Angle Z is just 180 minus those two angles, so that's just going to be 31 degrees. So angle Z equals 180 minus 90 minus 59. Okay? Now when it says solve the triangle, what it means is find all the angles and all the sides. So now to find the hypotenuse, what we could do is we could use trigonometry, or we could use Pythagoras. Since it's a right triangle, we can go a squared plus b squared equals c squared. We haven't really touched on Pythagoras as a review in this lesson, so let's just stick with using trigonometry to discover the hypotenuse. Okay? So our objective is to find xz, this hypotenuse right there. Okay? So again, let's use this. That was 59 there, that disappeared, sorry about that. Okay, let's use this angle, angle x, to find it. So, based on this angle, we know this side right there, and we're trying to find this side. So it's opposite over hypotenuse. So looking back up here, we see that that's opposite over hypotenuse is the sine ratio. So sine, let's write that down. So sine x equals opposite over hypotenuse. But we know what angle x is. Angle x is actually 59, and we know what the opposite side is. The opposite side is 10. We're trying to find out the hypotenuse. So sine 59, the 59 came from x, is 10, the opposite side over the hypotenuse. Now on the right side we have a fraction, but on the left side we don't have a fraction. So let's make a fraction on the left side as well. So anytime you have a number or a variable or anything that's not in fraction form, it's always over 1. Okay, so now that we've established that, that's a 1, we can cross multiply. So the two numbers across from each other get multiplied, and then the third number gets divided. So the hypotenuse equals 1 times 10 divided by sine 59 using cross multiplication, which gives us 11.7 centimeters. Another way you could have done it is, you have if you all remember the Pythagoras' theorem from grade 10, is you have a right triangle and you have two sides. So we'll label these sides A, this side B, and this side C. And we can use the formula a squared plus b squared equals c squared to discover what the hypotenuse is. So that would look like 6 squared plus 10 squared equals c squared. So then 36 plus 100 is c squared. 136 equals c squared. And now to get rid of this squared right here, we do what's called a square root. So c equals the square root of 136, which is about 11.7. So we end up with the same answer. Alright, let's do some examples. So we're trying to find angle x right here. Okay, and so first step is to label OA and H in terms of O, where O equals the opposite side, A is the adjacent side, and H is the hypotenuse. So we're looking at this angle. That means that this is the opposite side, this is the hypotenuse, and this is the adjacent. So what two sides do we have to work with? We have the opposite and the hypotenuse. So remember SOHCAHTOA. Okay, so we have opposite and hypotenuse, that's sine. So sine x equals O over H sine x equals 5 over 8. So then x is equal to the inverse sine of 5 over 8 which equals 39 degrees. Alright, let's go ahead and do the next one. So again, we're looking for angle x over here. This is the opposite side, this is the hypotenuse, and this is the adjacent side. The two sides that we have to work with are the adjacent and the hypotenuse. Get in the habit of circling the sides that you're going to be working with, just as I'm doing. It will help you a lot. So adjacent over hypotenuse, that's cos from SOHCAHTOA. So cos of x equals a over h. Cos of x is 9 over 14. That's because 9 is the adjacent side and 14 is the hypotenuse. So x equals inverse cos of 9 over 14, which is about 50 degrees. That's a really terrible 50. One sec. There we go, 50 degrees. And that'll end the SOHCAHTOA review.